Hello everyone. In this lecture, we will be learning about sets. So we have already learned about lists, tuples, dictionary, and now we'll be learning about sets, which is the last data structure in our curriculum. So first, let's understand how do we represent a set. So it's very simple. As list and tuples, just we put the second bracket. And we have already discussed all of them. All right. So I've taken a set consisting of apple, banana, mango, and 2. Now let us perform the different operations that we have. First one is accessing the items. So this is as simple as it gets. We have done this a number of times. One thing that is to notice over here is, since sets are unordered, therefore it is not really possible to access an item using the index, right? So we cannot really, so let's understand this. So let's copy this particular set. And let's say you want me to grab apple, right? So I cannot necessarily do this. This would throw me an error. Why? Because as it also says, set object is not subscriptable. That is, since it does not have any index, it cannot take the values. It doesn't understand what do you mean by s of 0, because these are not indexed, right? These are not ordered. So how do we access elements inside a list? Well, the only option is to get all of them together using a loop. That's exactly what I've done over here. For I in S, print I. And I'm exactly getting all of this elements. Now note that, unlike in list and tuple, we cannot use the range function over here. Because as I said, it does not understand any index, right? So let's again see what happens. For I in S, okay, let me use another. For I in range. Again, it's just a waste of time because ln of S doesn't, ln of S is 4, right? So now what we need to do is for I in range, right? So print I, it would definitely give me all the numbers. But when I write print s of I, it would throw me an error. So that's how it operates, right? So I hope you get it. How do we access items? By simply getting all these items. Now, one other way is we can store the items from sets into another data structure, for example, list, and then we can do all of the manipulations. Those are called using different data structures, and that is what we necessarily do, and we'll be coming to all those things later as we move forward with the course. But for sets, let us understand all the operations that a set does, and later we will combine to permutation and combination and understand each and everything in detail. All right. Now, what about changing items? We can necessarily, okay, so let's read from here. It says that once a set is created, you cannot replace any item. So once it is created, I cannot replace an item. Necessarily I cannot, because I do not know at which index apple is present, right? Let me show you one important and interesting thing over here as well. So what happens is, let's say I'm creating a list, right? You might expect that apple is located in the first place, but no. When I print this list, see, 2 comes over here, apple, then banana, then mango. We do not actually know which item is present. We only know that each of the items mentioned will be present and present only once. That is the beauty of set. Therefore, we cannot really replace a set, right? We do not know where or in which index or in which position these items are present or elements are present. What we can do though is we can remove and add elements. So here what I have done is s.add cherry, and cherry is added somewhere. I do not know where, but it is added somewhere. And this is how I got it. So it keeps on changing. Previously cherry was added somewhere, I forgot, but then now it has changed. Hopefully the next iteration it would remain the same. Yes, it remains the same, but then that's how it operates. I have added cherry, it got added somewhere. Now, same as in list, if you want to add multiple, elements, we use the update option. So s.update, I have used a list of elements, and when I print s, I get all of this together. All right. Now, one very important thing in set is the set operations that we perform. So first, let us understand what are the set operations. The first is the union. So let us consider two sets. All right. Let this be called as S1 and this be called as S2. Now, anything located here in the shaded region is to be termed as S1 intersection of S2. Oh, sorry, the intersection is, so S1 intersection of S2. This is the region. What is S1 union S2? This is basically the intersection region plus this region plus this region. So this is union. Necessarily, it can also be written as S1 plus S2. Now, S1 plus S2 means this region, Okay, let me make you understand in a different way. So S1 means this, S2 means this, and now this particular region gets repeated twice, right? That is the intersection part, gets repeated twice. So we can also write S1 union S2 equals to S1 plus S2 minus S1 intersection S2 minus this intersection part. All right. So now by examples, we'll understand how this has been operated. All right. So I've taken two sets. One is S1 containing 1, 2, C and D. S2, 1, A and D. So what are the common elements over here? 1 is a common element and D is another common element, right? So S1 intersection of S2 should give me 1 and D, because these are the regions. So 1 and D lies over here, and A over here, if this is S2, and if this is S1, here lies 2 and C. So S1 intersection S2 is 1, D. And union, that is S1 union S2, is all of them together. That is 1, 2, C, D and also A. 1 to ACD, right? So let's understand. So when I've written union, I'm getting 1 to DCA, 1 to DCA. When I'm doing the intersection, I'm getting A and D. That's precisely what we should be getting. Another is difference. What is difference? Difference means S1 minus S2. That's what I've done, S1 minus S2. So when I'm doing S1 minus S2, understand. So S1 contains 1 to C and D. If I subtract S2 from it, so I'll be subtracting 1. I will be subtracting A, but A is not present over here, so A is overlooked. I would also be subtracting D. The rest, that is 2 and C, remains as it is. Therefore, the answer that we get should be 2, C. That is exactly what we got, 2, C. So this is all about difference. Now let's understand the code over here. So what I've done is, there are 2 methods by which we can do the union. One is we use the OR symbol. This is the OR symbol, S1 or S2, which essentially means take this or this, that is entire thing. Or we can simply write S1 dot union S2. Both does the same thing. Exactly same. For intersection, we take the AND operation. Means this and this. Wherever the 2 common things, we might also use the intersection function, dot intersection. For difference, what we do is S1 minus S2, or use the dot difference function. So these are all the set operations that we have learned. Now set also has the remove methods as present in lists. So pop, remove, discard and clear, all very similar to list. Although discard is a new thing to learn, so we'll be doing that. So pop is quite same. You have all the items. Here what you do is s.pop and it removes any item. Now you necessarily do not know which item is going to be removed. See, removes only the last item. Since sets are unordered, we don't know which item gets removed. So pop is something that is there, but we do not necessarily use it. But yes, we definitely can know which item has been removed. Right? Now another important function is remove. It removes the specified item and it gives error if the item is not present. So quite similar to that of list. So what we have done over here is s is equal to all the names as previously, s.remove banana, and now when we print, we get the set without banana. Now when we try to remove an item which is not present, we get an error. So that is quite the same for list as well as set. However, in set we also have an option called discard, which is same as that of remove, s.discard banana, it discards the banana. But in case this item is not there, for example cherry, s.discard cherry, it does not give me an error and prints the set itself. The last remove function, that is clear, again as similar to that of list, it clears the set, and that's why we get a blank set. And unlike list or tuple, we do not get this. This we get in dictionary. Here we get set. This is a blank set. Now we also have the mathematical operations. So sum we also have the max and mean and the len as we have shown. So this was all about set. So I hope you have understood all the different data structures, starting from lists, tuple, dictionary, and set. So these are essential, and we will be using every single of them as we move forward with the course. All right. So thanks for joining in. This was it for this lecture.